Welcome to the NeuroDOT instructional video series. The goal of these videos is to explain use of the NeuroDOT toolbox to analyze optical neuroimaging data. Each video in the series focuses on a specific topic, such as software installation, data input, processing, light modeling, or visualization of results. The videos connect to PowerPoint tutorials included with the NeuroDOT distribution. The two resources are designed to complement one another, the videos providing background and context, and the PowerPoint presentations providing step-by-step self-guided exercises. These are typically paired with an M-file script that demonstrates how to properly implement a task using the functions provided in the toolbox. As the video series expands, deeper explorations of theory and computational issues will be included, but the emphasis of the initial selections are the basics. NeuroDOT offers state-of-the-art algorithms and standardized processing, but it will take practice to become proficient with the software. These instructional materials will help you develop the necessary skills to confidently apply these tools in your own research. The goal of this video is to get you up and running. We review system requirements, downloading NeuroDOT, setting system paths, and demonstrate some simple tests to check if your installation is working properly. Lastly, we describe how to work with the PowerPoint tutorials included with the distribution. Note this video covers using a MATLAB version of NeuroDOT installed locally on your machine. A Python version of the toolbox, as well as cloud-based processing through the Oxy website are also available. These are described in separate tutorials. The requirements for using NeuroDOT are minimal. NeuroDOT runs under Linux, Windows, and Mac OS X. Although there are no hardware requirements per se, HDDOT data tends to be large, and the processing is computationally intensive. More system resources will allow you to work with more complex data sets and complete an analysis in less time. The only formal requirement is that you are running a recommended version of MATLAB. The code has been optimized for MATLAB 2020B and may run poorly or not at all using an earlier version. No specialized MATLAB toolboxes are required. However, the parallel computing toolbox will be used for computationally intensive operations if it is available. This can substantially reduce the time required for processing. See the MATLAB documentation for help on installing and setting up the PCT. NeuroDOT may be downloaded from either GitHub or NITRC. Both sites include the same version of the software. However, there are supplementary files hosted on NITRC that may be of interest to some users. To download NeuroDOT from GitHub, navigate to the URL shown here. Click the code button to download the software as a zip file. Unzip the archive and move it to someplace accessible. If using a shared machine, be sure to set permissions so that all users can access the directory. Note GitHub may append the branch name to the file, neurodotmain.zip, for example. You may remove the suffix if desired. As an alternative, if you have Git installed on your machine, you may instead want to clone the repository. To do so, copy the repository URL and paste it into a git clone command. This will allow you to keep your installed codebase up to date by pulling any future changes made to the repository. NeuroDOT may also be downloaded from NITRC. Navigate to the NeuroDOT project on the NITRC website using any browser. You may then choose a version of the package to download in the pull-down menu. Note there are a number of files hosted at NITRC that are not available from the GitHub repository. Clicking See All Files will bring up a full list of content on a separate page. This includes support materials for NeuroDOT workshops, updated tutorials, example data sets, light model A matrices, and previous releases of the software. Select the checkbox of the files of interest, then use the download button at the bottom of the page. After you've downloaded NeuroDOT, it's helpful to familiarize yourself with the contents. The distribution is organized into 4 top-level directories: data, documentation, functions, and support files. The data directory contains files used in the NeuroDOT tutorials. These are mostly array data that has been processed for input, but also includes a few files used in other applications. The documentation directory contains help text for a NeuroDOT function that is displayed in the command window when using the MATLAB help command. The directory also contains a collection of PowerPoint presentations and M-file scripts that provide self-guided instruction on a range of NeuroDOT topics. More on use of these tutorials appears later in this video. Note, new tutorials are frequently added to NeuroDOT, so the files included in your distribution may differ from what is shown here. The functions directory contains the M files that make up NeuroDOT, organized by function. Most of these are only used internally, but a subset comprise the top-level routines that appear in the tutorials, as well as the analysis scripts you will write. Finally, the support files directory contains a number of files, mostly Nifty and MAT files, that are required for various NeuroDOT processing tasks. This includes atlases, meshes, parcellations, spectroscopy data, and a number of standard pad files. Whereas files in the data directory are usually specific to one or more tutorials, support files are used for general processing. Note the directory for A matrices. These are generated as part of light modeling, but examples may be downloaded from NITRC and moved here. Because these files tend to be very large, examples are not included by default. Before NeuroDOT can be used, it must be added to the MATLAB search path. This can be done either at the command line or using the Set Path button in the toolbar of the command window. To set up the path at the command line, use the Add Path and Gen Path commands. Here we have assumed the top-level NeuroDOT directory is under /applications/toolboxes, and we have moved NeuroDOT there after download. Specify the directory you have chosen for your installation. If setting up NeuroDOT on a shared machine, you may need to set permissions on this directory so that all users have access. The path addition created by the Add Path command will only persist for the current MATLAB session. You can make the addition permanent by using the Save Path command. The path may also be added using the Set Path button. This will bring up a file selection dialog box. Select Add with subfolders, then select the directory where you have installed NeuroDOT. Use the Save button to permanently add this to your MATLAB path. If you instead click Close, the path addition will only persist for the current MATLAB session. With NeuroDOT downloaded and the paths properly set, you can now test your installation. MATLAB should be able to locate any of the M files in the distribution. Verify this using the which command, demonstrated here for the NeuroDOT function used to plot raw time series data. If MATLAB is unable to find the function, check that your path setup is correct and that you have sufficient permissions on the install directory. Note you may view the header for any M file in the distribution using the help command. This returns a brief synopsis of the function, typically listing inputs, outputs, and usage tips. The which command will also work for MAT files. Here we verify MATLAB can locate sample time series data included in the NeuroDOT distribution. We will plot the data in this file. To begin, use the load command to input the file, then verify the contents using whos. This file contains time series data as well as structures that define collection and processing settings. Now we plot the data using the command shown here. This should open a MATLAB window and plot time series data at 2 wavelengths. Currently, the information provided in this figure may be unclear. You will understand how to interpret these plots and much more by the time you complete the NeuroDOT tutorials. Earlier, we noted the NeuroDOT distribution contains a collection of PowerPoint tutorials and M-file scripts that provide instruction on a variety of NeuroDOT topics. Many of the same topics appear in the video tutorials hosted on YouTube. One is not meant as a substitute for the other. Rather, the two collections are designed to work together. Whereas the videos provide background and context, the PowerPoint presentations offer step-by-step instruction, guiding you through the accompanying M-file code section by section, and in some cases line by line. Consider data input as an example. The video tutorial includes a brief review of the file formats used in optical imaging, gives an overview of the file structure, and describes third-party tools you may need to install in order to work with these files. In contrast, the PowerPoint tutorial simply catalogs the NeuroDOT functions used to read these files and describes the MATLAB data structures they create. The background provided in the video tutorial might not be necessary to a user simply interested in hands-on instruction, and so is omitted in the PowerPoint presentation. Conversely, the coding details which appear in the PowerPoint tutorial are not well suited to video presentation. The content in one format complements the content in the other. As such, you'll want to make use of both tutorial formats, viewing the video for a given topic before working through the guided exercise in a related PowerPoint presentation. Once you have successfully installed NeuroDOT, you are ready to begin learning how to analyze HD DOT data. As a next step, you may want to review the Getting Started PowerPoint tutorial, which includes a few details not covered in this video. Additionally, you may want to install NearFaster sooner rather than later, as this toolbox is required to work with the tutorials that involve light modeling. Additional information may be found in the resources listed here. Feel free to contact the development team with questions or post them in the comment section below. Thank you for your interest in NeuroDOT.